Roger once again, Mud Fossil University, on the quest for health, and in that regard I have been studying bacteria, because bacteria is more than an invasive little thing that bothers you. It is the thing that makes you healthy. They are the people that work for you, the little guys inside of you that do everything you need. So let's treat them like little people and pretend that they have needs just like we do. Right? So what are we looking at here? What I had decided to do was, I know that the transition metals are created by enzymes. The enzymes are created by the bacteria. The bacteria have to be happy. They have to be taken care of, just like you little farm animals. If you want them to lay eggs, you got to give the chicken feed. You can't let them get sick. All right, that's what's happening to bacteria, getting sick, because some of them are not there anymore. So what we need to do is decide what is it you need, and how do you keep them happy. So I started looking into what is it that they have discovered through the course of time. Is there any biomarkers? And sure enough, I go back to 1997, and they show an analysis of fecal populations of bifidobacteria and lactobacilli, an investigation of the immunological responses of their human hosts. Exactly what I've been looking for. But they just picking up two things. That's all right. So now, what is the takeaway from this? I read the whole thing, and it's interesting, but it doesn't shed a lot of light, other than the fact that these characteristics seem to run in the genus rather than the species. It's a little more broad. It encompasses more species. It's in the genus. Anyway, if you can affect the genus, you can normally affect all the species that are in that genus. That's my takeaway. I could be wrong, but that's the way I read it. Now, what else is there to take away from it? Now, listen to this. It says, the bifidobacterial and lactobacillus populations of fecal samples collected from 10 human subjects. Only 10 now. 5 women, 5 men. They range between 20 and 50 years old. They didn't do any special preps with them. They just said, do what you're doing. We're just going to check you out and see what lives inside of you over, I think it was like 6 months, 9 months, something like that. But anyway, they took several samples. Now, so they had 10 human subjects were studied. The numbers of bifidobacteria, now listen to this now, the numbers of this particular one, bifidobacteria, were similar in the fecal samples of all of the subjects. That's important. They were similar quantities and the same bacteria in all the subjects. And this is a very, very interesting bacteria. We're going to go into it in a minute. Now, what else is there about this? But the lactobacillus numbers varied even between samples collected from the same individuals. Well, we got to look into what is lactobacillus. It sounds like it's got something to do with milk. So we got to look into that now. So, and then it goes on, the analysis of population, of bacterial population, and so forth. All of that stuff really is meaningless after that. That is the main takeaway right there in the first couple sentences. So we don't forget, it seems to be the antibodies in your immune system react to genus rather than species, apparently. So it's a broad range of species in a particular genus, and if you can, and your immune system will recognize the genus, and therefore the individuals that are in that species. That's the way I'm taking it. That, again, I could be wrong, but that's the way I'm taking it. And the reason that the species, genus versus a species is important is that every type of life has certain characteristics to it, and they're a little bit different from other life. That's why they're separated, and the genus of this particular type of life has some characteristics we might be able to go after, such as cell walls, which I believe is the characteristic they go after in bacteria, because it has some vulnerability. Let's put it that way. Anyway, let's look at this particular one. This is the one that's important to look at. All right, there's a sweet-looking name there again, bifidobacteria. No, bifidobacteria. That's the name of the bacteria that we're looking at. So here's what I decided. I'm going to look into this. Well, where does that come from? Is that something that everybody has? Everybody should have it? Do you have it when you're born? Well, sure enough, all those things that seem to be a fact. If you go down through this paper about this, it talks about members of the genus. Again, that's the genus. Bifidobacterium, which has probably some species within it that are different here and there, which you'd have to know. You can't just go for this one thing and say, oh, it's all that thing. No. There's going to be different little things in there that also have particular jobs. And they may even be, I'm telling you, it's just absolutely amazing. They may even be so specific that there's some of this stuff in there that is able to hook up with 2 electrons and 3 electrons and 4 electrons. Different species within that genus. That's what I'm saying. It could be that specific. What we need to do is to be able to see these things in a spreadsheet, analyze them, be sure that we understand quantities and amounts. Right away we know that this is supposed to be approximately the same in everybody. Already, even with 10 people, we sort of have seen that. So there's a lot to be drawn if we can just get these numbers. That's all I'm asking for, is a database. That's all I'm asking for. And in order to know what these numbers mean, the bacteria, we have to know what metals are in your body and the minerals, because these are the things that harvest and break them down and deliver them to the blood. Right? Well, I mean, they work with enzymes, and it's just a dance. It's a total set of workers that are out there doing a job that they are programmed to do. Somehow somebody programmed, and I'm not going to go into that, but it certainly was not accidental where a big bang blew up a bunch of dead dust and it all ends up with this. Absolutely impossible. I don't care. There is not enough eternities in eternity and infinity to have this happen from dead dust banging into each other. I mean, that's the weakest minded argument I've ever heard of. It's exactly like saying, well, it just happened. Here it is, it just happened. And then it's pretending that you understand it. That's the key that blows my mind. It did just happen. I can't disagree with that. But I can disagree with the fact that you have even the slightest clue as to the actual method. Anyway, it drives me nuts, that one there. Jeez. And if you don't believe that, they'll fail you in life. Oh my God. And if you believe that there is a God and a creator that did that, they'll call you some kind of a cult wacko. And it's exactly the opposite. As far as a cult goes, if you can show me one that fits better than academia, boy, I tell you, I would love to see that one. Give up your beliefs, give us your money. We'll tell you if you're going to be successful in life, and if we say you're not, you ain't going to make it, pal. So you better do what we say. Anyway, that's the story in academia, which I've been saying, but that's just the way it works. Yeah, there's one of my academic buddies there right now. We'll be talking later. All right, that's the story about bifidobacterium, and it is in infants. Let's see if we can come up with something about that. All right, this is really interesting, because I was thinking to myself, you're probably born with what you need to destroy the things that are going to try to destroy you. Or you acquire them quickly, hopefully. Now, I know animals, they actually force their babies to ingest feces that's already got this microorganisms in them to break down cellulose and things like that. I know that happens in elephants and other kinds of animals. Now, so I decided, well, it must happen in a baby too. And in my kids, I let them scratch themselves and do all kinds of play in the mud. That would have been what would have happened to them in nature, in life. So, and they've been healthy. So, and I never gave them any antibiotics and any of that stuff. All right, so let's go into this now. So I decided it must be in the babies. So I start looking. So they go, past 20 years, they've been research focusing on the members of the gut microbial exhibit health-promoting probiotic effects, such as protection of the host against pathogens. Boom. 20 years, they've been looking into this. Okay, so now I keep reading, and then I come down here, and here we go with the gastrointestinal tract. Microbiota have been linked to certain gastrointestinal diseases such as inflammatory bowel disease, necrotizing enterocolitis, all kinds of different diseases. Particular interest is focused on members of the genus Bifidobacterium. There's that name again. All right, so what else? Some of which have been included as live components in a variety of so-called functional foods. All right, and I believe that's in your yogurts and things. Now, Bifidobacteria were first isolated from the feces of breastfed infants in 1899. I asked about this. Nobody knows. Well, I don't know. 1899 it was doing it. And since then, Bifidobacteria have been isolated from a range of different ecological niches, such as the oral cavity, sewage, and the insect gut. All right? This is absolutely, universal, it sounds like, in biology. Babies get it from breastfed milk. I mean, these are things, and they stopped breastfeeding. I don't think I was breastfed. My kids weren't breastfed. And, and as a matter of fact, I'm going to tell you a story. When my kids were little, my son, the first one, he was a little, they say colicky or whatever they call it. He's always squirreling around there when he was little. So I said, wait, he's got a problem with his stomach. It's either, all you want to do as a little infant like that is eat or poop. It's just one or the other. So he was getting bound up. And then there was this other formula that he would take. It would make him too loose. So I ended up mixing the two of them together, and it ended up being good. And I said that to the pediatrician. I said, we give him, I split this one and that one, and we mix them together. And he said, well, I don't know if you should be doing that. I said, why not? It works. He said, well, I never heard of it before, but if it's working, and sure enough, it worked, and he was fine. And the other thing I would do was when they would start getting fussy, like, I would actually lift them up under their armpits and sort of just wiggle them, just gently sort of roll them. I would call it a belly roll. And all of a sudden you'd hear, and they're fine. It's just like you and me. It's just like you and me. You just had to work that baby down. And basically, that is health. You take care of your intestines, you're a healthy puppy. That's it. The case is closed. But once that bacteria in you stops doing its job, now you got trouble. And that's tough to get back there going and put them back on the job. So we're looking, I'm focusing in on this stuff right now. So I'm looking deep into this to find out if there's anything else we can determine about this and what it does and how it works. But it is involved in breastfed infants in 1899. Obviously, you need this stuff. It's being introduced into you. And it's in sewage, and it's in the gut, and it's in the mammals, and recently found in water, kefir, whatever that is. Now, so I would think you'd test for that if you had a disease or a bowel issue or really almost for anything, because it has that job of doing something down there, cleaning something up, killing something, creating something. I don't know what it's doing, but it's obviously a very important component of your overall intestinal health. So let's look a little deeper into that and see if we can find anything else. Well, they're saying, though, although it has been well established that bifidobacteria confer positive health benefits to the human host, there is a clear lack of knowledge concerning the molecular mechanism that explains these probiotic traits of Bifidobacterium. Deciphering whole genome sequences can shed light on the genetic basis of the probiotic actions. They're always looking for a genetic basis of this and that. The genetic stuff reacts to what you put into your body. It's not the other way around. It's not because your genes are a certain way that your body reacts to the way your genes are. I mean, I'm not saying that in every case that's true. I know there are defective genes. Absolutely no question. That's not my point. But in the general population, you don't go looking for a defective gene because the guy's got an upset stomach. It just doesn't make sense. And they don't consider this to be that important, because what I keep being told is, well, everybody's different, so you couldn't get a database that would be meaningful. I said that's insanity. That is insanity. Everybody is different because there is so much complexity, and that is why you need the database. Because copper may affect the magnesium, so it's not just the copper that's low. The magnesium may have interacted with the copper to cause the copper to be low, but now your magnesium also has a problem. So it's such a huge ball of data in two sections: your fecal species, everything that's in there, every little bit that's in the feces. What are you excreting? What is going out of you? That means what is living in you. All right, and what didn't get consumed in you? What should have got consumed in you that didn't get consumed, or what got consumed that shouldn't have got consumed? Now, what about the bacteria? The bacteria are the things that, what about the blood? All right, we've handled the bacteria. We know what we got for bacteria. Then we find out what we have in our blood for the metals and minerals and all the chemistry of the blood and quantities and values, and then we can match those to a set of norms, or averages. They don't have to be norms. You might be a little different than somebody else, but you should at least be able to see what seems to be an average, because I guarantee you, no question whatsoever, there's going to be relationships drawn, no question whatsoever. And already they know that autism people have 40% less bacteria. That means the metals and so forth that are being created and harvested by bacteria are not being created and harvested, or not being removed by that bacteria. There is just a total enormous amount of interactions. And once we can understand these in a significant relational database and point to the symptoms that always seem to happen when the copper is below 27%. This guy's got itchy skin. Whenever the manganese or whatever is below whatever certain number of moles or quantity, grams in the body, there's no electrical conductivity. The guy's got heart issues. It's just so specific that it will fall into these patterns. So if there's a fight about saying that this is just it's just too complicated, it'll never pay out. Of course it's going to play out. That's the reason you have to do it. It is complicated. There is so much chemistry in your body, and if I go out to eat something that's a certain fast food, or something that's prepackaged and so forth that has preservatives in it. I mean, the preservatives in there so that it can't break down. I mean, so then you eat it and you expect that nothing's going to happen with that. Of course something's going to happen. It's going in your body. Something's going to happen to somebody. Some little thing in your body going to have to deal with that. I'm not going to just say, oh, I'm sorry, I shouldn't have been here. I'll just sit over here in a corner until you poop. No. It's going to say, what are you guys doing down there? Hey, give me some of that. No, you stay away from that. Yeah, like hell. Try to make me. And then you have all, that's the way the body works inside. They're fighting all the time. So you better have guys that are tougher, and you better feed them good. That's just the way it works. Take care of your fighters, and they will fight for you. They're saying that this bacteria can investigate potential bifidobacteria to prevent and or treat colorectal cancer, diarrhea, treat various gastronomical disorders, necrotizing enterocolitis. Everybody seems to get that nowadays. Lower incidence of that when you have routine administration of B. brevi. So they're giving them some kind of additional bacteria, and it lowers down that kind of a problem. Inflammatory bowel disease. Although the exact mechanism of action not understood, reduction in the symptoms following treatment probiotic strains. It's so freaking obvious that it's just unbelievable. Colon regularity. And I mean, I know this from my own self. Every time anything I ever had done that infected my intestinal tract, I end up with problems. Antibiotics, when they give you that prep for a colonoscopy type of thing, it all affects you internally, and then you got problems. And then they give you functional foods that are going to add these things to you, and so forth. There's a lot of information here that should be looked at, and carbohydrate metabolism. Human genome predicted to encode just 8 of these genes to directly link to digestion. Therefore, many complex dietary carbohydrates remain undigested and end up in a colon where they may be degraded by members of the microbiota, so on and so forth. And it goes on about how the human, it's a factory, it's a chemical system that you need everything in place in the right amounts here and there, and the right guys to go out and do the right jobs. And if all of this stuff is there, you're going to be okay. This thing goes on, goes on and on and on. So, but there's a lot of information, but nobody's really putting this together, in my mind, in an informative way, so that you can see what metals and what bacteria and what different diseases and all these things will come to pass. Now, there's more to the story. All right, here we are back again. What is this? Bifidobacterium. And what are we talking about now? Elevated fecal pH. The pH is becoming elevated indicates a profound change in the breastfed infant gut microbiome due to reduction of that bacterium over the past century. So now we got a new understanding that's going on. Something has caused this bacterium to have reduced its intensity in the human body. Well, why is that? Well, guess what? It appears to be related to advanced societies, which we call them advanced. Anyway, historically, this species were reported as abundant in breastfed infant gut. Abundant. There was tons of them. However, recent studies in resource-rich countries, such as the United States and so forth, show an increased abundance of taxa regarded as signatures of dysbiosis. All right, this is a problem. It's unclear whether these differences are the product of genetics, geographic factors, interventions such as formula feeding, antibiotics, cesarean section. Fecal pH is strongly associated with this particular bacteria abundance. Strongly associated with this abundance. pH, fecal, strongly associated with that. So what are we talking about? Thus, pH could be an indicator of its historical abundance. A review of 14 clinical studies published between 1926 and 2017, representing more than 312 healthy breastfed infants, demonstrated a change, now listen to this, in fecal pH from 5 to 6.5. That is huge. That's huge. This trend of increasing infant fecal pH over the past century, consistent with current reported discrepancies in that bacterium species abundant in the gut microbe in resource-rich countries, compared to that in historical reports. They're going back 100 years and looking at what happened over the last 100 years. The analysis shows increased fecal pH and abundance of members of the families, I don't know, Ectobacterium, Clostridiacea, and Peptorostostatacesa. Where did he come up with these names? Where did he come up with these names? Peptopostapestabistica and Velionolesicia are associated, indicating that loss of highly specialized. These guys are getting taken over by these guys with all these extra little syllables. Anyway, bifidi, my buddies here, species may result in, once you lose these guys, you got dysbiosis. Whatever that means. The implication of which are not yet fully elucidated because you can't understand the words they use. They always try to make everything so convoluted that you can't figure out what they're saying. That keeps them on top. All right, critical assessment of interventions that restore these ecosystems, measured by the key parameters such as ecosystem productivity, gut function, and long-term health, are necessary to understand the magnitude of a change. Let's read that again. Critical assessment of interventions that restore these ecosystems. This is when we're going to be putting people in a database, and then we find out you give this, you give them that, and all of a sudden it's restored. We need to know how to restore these things. Critical assessment of interventions that restore these ecosystems. Absolutely 100% necessary. We have no clue. No idea how to go put them back together now. So we have to measure the magnitude of this change, and everybody's getting sick. The kids are getting autism, they're getting all kinds of allergies, and they can't eat peanut butter. You can't do this, you can't do that. You can't, fish touch you, you blow up like a balloon. I mean, something's not right. There's problems. And this is not something that, when I was a kid, you eat anything you want, you did anything you want, nobody ever bothered you. Everything was fine. And I go back a ways, but I'm not 100 years old yet, not quite. So I don't know. It's things have changed. There's no question they've changed since my youth. I'm almost 100% positive of that.